So in this session, we are going to learn a little bit more detail about the relational database model. And we have already learned about the relational database model basically uses this, the rows and the columns. That is what we have already learned. And it is basically developed by the great, veteran in this field, E.F. Cott, in the year 1970. And data, the relations, how they are organized as tables, and all these things basically could be even managed with the help of RDBMS systems, Relational Database Management System. Now, moving over to how the relational model is basically classified. Yes, we have seen the basic building block of a relational model as the entities, the attributes, the keys, the constraints, and everything. And the set of the operators by which it's nothing but the various options with which we could retrieve the data from the database. Basically, we use the relational algebra. And to dive deep into this, say the data is basically represented as relations. So what do you mean by a relation? As we have already learned in the previous slide, like a relation is like, say, for example, in the university, you can have in the university database, you could have multiple relations or multiple tables. Like you can have a student table, you can have a course table, teacher table. So relation is nothing but it is depicted as a table. And now the columns represent basically the attributes. The attributes in the sense, these are nothing but the characteristics. Say if you consider this particular relation or this particular table, the customer table, when you look at it, this customer ID, customer name, status, these are the basically the attributes. And each row, one Google active, it is basically one particular tuple. So we have already seen this is just a recap. Now moving over to the tabular representation of the relational table, when you could see this, a table, and you can have attributes, and each one is called as a row, and each cell could be called as a cell or a field. Now when you look at the relation, you have multiple parts for it. I mean, like you can have a schema. Schema is nothing but student names, scores, grade. If you take this particular part, this is the schema. That means the structure. I mean the column headers or the attributes of the database. Instances are nothing but the data rows. This we have already seen. Now comes the relational database model. I mean like the model objects. So a relation is basically, say if you look at this, you will have a customer number and customer name, customer add, and the credit limit. So these are basically the model objects. I mean like this is the schema. And there is a body. Body will have this various instances in that. So when you have this, you could say that this is the relational body. They are nothing but the instances. And as you already know, this is your schema for this particular table. So student courses taken is the table name, and student name, course, grade. So these represents, this attributes basically represents the schema. And there is something called degree and cardinality which you need to know. So what do you mean by degree? So degree is nothing but the number of the fields or the attributes in this particular table. Say you have this courses taken. So the degree of this particular courses taken table is particularly 1, 2, 3. That means 3 attributes are there. And the same way, cardinality is nothing but this 1, 2, 3, 4. That means how many rows or tuples or records are there in this particular table. That will give you the cardinality. And now, can you write down the schema for this? So here, the table name is instructor. So instructor, within the parenthesis, you will have ID, comma, name, comma, department name, and salary. And what is the degree and cardinality of this? Yes, the degree is basically 4 because you have got 4 different attributes and you have 12 different rows. So this is the cardinality. So the basic building models of the data model, which we have already seen. So this is what we have seen. So you have entities, relationship, attributes, and constraints. These are the basic building blocks of a particular model. And there are 3 different types of representation for relationship. One is the Shen model and one is basically the cross-foot model. So this is the Shen model, where you have an entity or a student table or a relation, whatever the way we call, and followed by all these things are basically the attributes. And in the cross-foot model, you could draw this whole table as a student table, and all the items are given over here. Say if you have student ID, you could even say this as the PK here, but you should understand that there is no PK. So if there is a primary key which is actually given over here, it will be actually shown here in this particular section. And yeah, we need to know certain terms. So domain is basically the set of the atomic values used to model data. I mean, like, domain could be a set of acceptable values. A column is, that means for a particular table you can have multiple attributes. So each attribute, okay, what could be its name, what is the data type of it, what is the format. Say you have one particular attribute called gender. It can have M, it can have small m, or it can have capital M, it can have small f. Like, these are the different domain values of this particular attribute gender. Now, what is a null attribute? So null is basically, say, in your student table, there could be chances where you don't have certain values actually given over there. So if you don't have certain values, if you have any missing values, then basically you can actually use it with null. Okay, so the values that does not exist, the value undefined, basically could be used as null. Now, what are the various different type of attributes? That is very, very important. So let me first of all tell you. So a domain, I mean, like, a domain is nothing but the various attribute values. I mean, like, for a student table, you can have multiple attributes. Each attribute can have multiple values, different type of values which could be entered into that particular field. That set of values are called as a domain, right? And this attributes itself could be divided into multiple types. So it could be atomic attribute, composite attribute, single valued attribute, multi-valued attribute, which is very, very important for us in the relational databases, and stored attribute, derived attribute, null valued attribute, key attribute. Don't worry by all those, it's all very simple. So now let's understand what is an atomic attribute. So an atomic attribute is that it is very clearly written here. It cannot be divided into smaller independent attribute. Say for example, you have customer ID. Okay, say you have gender. Say if you are a male or a female, you cannot divide it any further. Say if you have a customer number, mostly say if you have a student ID 1, the 1 cannot be divided any further. Okay, so you could say that something which cannot be divided any further can be called as an atomic attribute. Now the next one is composite attribute. It is also very simple. So composite attributes are those attributes which could be divided into smaller independent attributes. Say you have customer name. Say the customer name could be divided in as first name, middle name, last name. So then we could call it as a composite attribute. Date of birth. Here, date of birth cannot be divided. Now the other attribute is nothing but the single valued attribute or a multi-valued attribute. So an attribute that has got only one value, okay, is called as a single valued attribute. And an attribute which can have multiple values are called as the multi-valued attributes. That means that, say, a student has got a student ID. So one student will be associated with only one student ID. So it is a single valued attribute. Multi-valued attributes. Now every single person, most of the people whom we see has got two different phone numbers. So in one cell itself, say for Alex, who has got the student ID 1, has two phone numbers. So I will say phone number 1, phone number 2. So you have multiple values which could be entered over there, multiple email IDs which you have. So you could say that this customer name, customer ID, the gender, door number, everything will be like single valued attribute, but at the same time your phone number could be multi-valued attribute. Now comes the stored attribute and the derived attributes. So an attribute that cannot be derived from another attribute is called as a stored attribute, and those attributes which could be derived from other attributes are called as the derived attributes. So say for example, you have an attribute called date of birth. From that, if I get to know about your date of birth, I can definitely know about your age. So I could say that date of birth is a stored attribute and age is a derived attribute. Now comes the example for null valued attributes. So those attributes which does not have any value which is given over there. They are nothing but the null valued attribute, and those attributes which are unique to a particular table are called as the key attributes. So if you could see that this customer ID could be called as a key attribute, and yes, and if there is any values which are not given there, could be called as null, could be written as a null attribute by giving the value null. So now in this particular example, can you identify atomic, composite, single valued, multi-valued, and null valued and key attributes? So atomic attribute could be called as one example for the atomic attribute is ID. And composite attribute, it's nothing but, say, if I take the phone number, I could say that, okay, 91, that means that, okay, it's from a particular country followed by the number. And single valued, say a particular person can, for a particular course, can get only one grade, single valued, and the ID single valued. And multi-valued, say if I am writing both the college address and the home address, this address field could be a multi-valued attribute. Say if some of the information like the phone number is not available for Harry Potter, then I could use it as a null. And the key attributes are those attributes which are unique to this particular table. So I could say that ID is a key attribute. Hope you understood and hope you follow me. So this is kind of a small summary about all the different attributes. So consider the student entity. So student email is basically the primary key, and middle name, first name, DOB, these are all the various attributes. Okay, and so simple attribute which cannot be subdivided, composite attributes which could be subdivided, required attribute means that should have a value, optional means that may or may not have a value, single valued attribute that can contain only one value, multi-valued attributes that can contain multiple values. Key attribute is those which cannot repeated or should be unique. Non-key attributes which can have repeated values, and stored attributes which is actually supplied. I mean, like you cannot derive it from anything else. Derived attribute, you can derive it from some other attributes. Now moving over to it. So now we know about the various constraints, various attributes. Now we are going to see about the constraints and the keys and the constraints. So there are various kinds of keys in a table. So in a table, if you could see, we have already seen about the primary key and the foreign key. The primary key is basically one key attribute which can uniquely identify one particular record in the table, right? So it basically gives you about how to find out the relation between two tables. So there are different type of keys. So foreign key, super key, candidate key, there are different type of keys. So we'll have a look around to different keys and to understand more about. So there is a flow which has to follow to understand about the various kinds of keys. So let's get started. So the first one is basically the super key. So super key is like any combination of attributes, like say this is a student table and you have two different attributes. One is S name, one is roll number. So say there is a specific combination of attributes which can uniquely identify this table. So when you look at this, I could say that S name alone can identify this particular table. No, why? Because Ram is basically repeated twice. So I cannot consider S name alone as one of the key to uniquely identify each and every row. So when I look at this S roll number, yes, each one of the values are basically unique. So I could say that S roll is basically one of the key which can uniquely identify. Now, I can also give you another suggestion that is nothing but a combination of S roll comma S name. Say if I take this combination 123 comma Ram, yes, there is only 123 comma Ram, and 124 comma Sanjay, yes, this combination is only once. So my keys understand that the keys can be a combination, can be a single attribute itself or a combination of multiple attributes. So I could say that I can have my super keys as S roll alone, or I can also have a combination of S roll comma this S name comma S roll. So this combination can also act as a super key. That means these combination can uniquely identify each and every row in this particular table. Now can you identify the super keys in this particular table? So if I could say that book ID is one of the super key, then I could say book ID, then I could also say that I mean name and author, this combination, and I could also say book ID and name, yes, book ID and name. and I could also say that book ID and author, this combination. So all those, permutations and combinations basically could be a super key. But the only issue which you have to keep in mind is that in super key you can have redundancy. I mean, what do you mean by redundant? Redundant is that, say, book ID alone can actually uniquely identify each and every record in this particular table. But at the same time, these three combinations like book ID, name, author, this can also this combination is also a super key, but that is redundant. Why it is redundant? Because in this particular combination, name, author can alone, uniquely identify all the records. Book ID alone can identify all the records. But here, we basically have a combination of, book ID is also there, name, author is also there. So it is redundant. We don't need such kind of data because it is redundant data. So that is nothing but the redundant attributes. So in this particular combination, if you could see, I could say if I consider book ID, then name, author is a redundant attribute. Or if I consider name, author, I could say that book ID is a redundant attribute. So that's what is redundant attribute. Then comes the candidate key. So what do you mean by candidate key? So candidate key is that a super key without redundancy. That is what exactly we want. So if we consider all these four in this book ID name, name, author, book ID, name, author, I could say that my candidate keys are nothing but book ID and name, author, because if I take this one, book ID is repeated, and if I take this one, name, author is repeated. Okay, so which makes my keys redundant. But candidate keys are those keys, the super keys, which are not redundant. So this is not redundant, this is not redundant, because these two values are required in order to uniquely identify each row. Book ID is required in order to uniquely identify each row. But if we take this, I don't want the name information at all. It's a redundant information. Simply by keeping the book ID itself, I could actually get this information. And if you take this, both of them are basically, primary, combination can act as the primary keys. So I don't want this two information together, which is redundant. And now comes, identify how many super keys can be there in the above table. So there could be many super keys. So employee ID, so all the permutations and combinations could be there. And now can you identify the candidate keys? Okay, so when you consider the candidate keys, this is how you will do it. So when you take the employee ID, yes, employee ID can uniquely identify each and every row. And when you take the employee number, yes, it can uniquely identify all the records in the table. But when you take employee ID and employee number, is it required? No, there is a redundant attribute. You can either keep this or that. So there is redundant attribute. So they are not candidate keys. And then when you take this employee ID and employee name, yes, because we have employee ID, that itself is alone. This is not required. So that's redundant. And when you take employee ID, employee number, employee name, of course, it is highly redundant because we just need only one. And employee number and employee name, yes, we don't need, because employee number alone can actually uniquely identify the data. So what are the candidates which you could see? Employee ID or either employee number could be called as the candidate keys. All the other ones are basically, so this is a bunch of super keys where you could have to take those keys which are not redundant. Super keys which are not redundant, nothing but the candidate keys. Hope you got it. And now coming over to primary key. So primary keys are those keys. So primary keys are nothing but one of your candidate key. So in the previous example, you identified that either book ID or name or author could be one of your super keys which are not redundant or which are the candidate keys. So you can either select book ID or name author. But how will you select that? That will be basically the job of the database admin or the database designer, because each one of them can uniquely identify the number of the, uniquely identify the records. So whichever is more appropriate for your application, you can choose that. So in this also, you have to select either employee number or employee ID, but that will be done by the database admin or the database designer. And now there is something called secondary keys. So say you have employee ID and employee number. In that, your database admin selected employee ID as the primary key. So you have this employee number, right? So that employee number is basically called as the secondary key. So the candidate key, which is candidate 4, it could be used as a primary key, but is not yet used. So such keys are basically called as the secondary keys or the alternate keys. And now thinking about the keys, you can have your whole super keys, and then you can have the candidate key, and from that you can also have the primary keys. So is everything fine here? So this is your question. So if you look at this, how did you get the department name of a teacher, Sarah? So you want to find out, what is the department name of the teacher, Sarah. So in such cases, you have a department table, you have employee table, but yeah, there is a relationship between them, but that is not mentioned here, right? So in such cases, basically what you have to do is that you need to include in the teacher table, you are including the department code so that you have a relationship with the department table. Okay, so you have a relationship now. So this is nothing but the foreign key. So foreign key basically is that they are the cross reference between the tables. So the primary key of the one table which is included as part of the table. Okay, so here when you look at it, department code is basically the primary key of the department table, okay, which is added onto the teacher table. So this department code will be acting as a foreign key to the teacher table, and it is basically a primary key of your another table. So this is your R1 and this is your R2. So R1 is basically referencing R2, and you could say that this is the referencing relation and this is the referenced relation. And now comes a small summary about your keys. So you have primary key, you have candidate key, foreign key, and you can also have the composite key. It's composed of one or more key attributes. So composite keys, and the foreign key is basically what you have seen just now. And now we will move on to the constraints. So the constraints are basically the rules which we are imposing upon a particular table. Okay, so the constraints basically called as integrity constraints because they ensure the data insertion, updation, and other processes have to be performed in such a way that the data integrity is not affected. That means you can do a lot of updation operation, deletion operation, insertion operation. So whatever operation you do, ultimately the integrity of the table has to be maintained. So there are different types of constraints that could be taken into consideration. So one is basically the domain constraint, the second one is entity constraint, referential constraint, and the key constraints. So these are the major ones. There are so many else as well. And when you consider the domain constraint, it is as simple as that. As I told you, say domain constraints are nothing but if you take one particular attribute, what are the different kind of values that could be included there. Say for age, if you consider the domain values, all the domain values has to be integer. That is what the constraint is all about. But you have something called a character here. So which acts as a domain constraint violation. Okay. So then comes the entity constraint. So entity constraint is nothing but the primary key cannot be null. But here the primary key is null. So this is an issue. So this issue will cause the entity integrity constraint violation. And now comes the key constraint. Key constraint is again your primary key cannot be repeated, or it has to be unique. So here if you could see that there is 102, there is another 102 which is actually repeated. So there is a primary key, primary key constraint violation or key constraint violation. Then the other one is basically the referential integrity constraint, which is seen in the scenarios for your foreign key constraints. So if you have a foreign key, so there could be a lot of referential integrity constraints. So say this is one example for the referential integrity constraint. This is something which you have already seen. But say if you have deleted one particular column here, so just imagine that you are actually deleting this particular department at all, then what happens is that in your teacher table, there is actually a department 002 where the Scarlett Johnson had worked, but now the department is deleted. So this referencing is like into null referencing. So it does not know whether where it has to actually, if you're deleting something, it can cause this integrity constraints, like in a violation on the integrity. And also you could think about this one, say a department code is which is here in the teacher table, but in your department table that code is not there. Okay, so that will cause a referencing issue. So these are the referential integrity constraints or violations that can happen. You will see more about it in the lab sessions. So adding, changing values, deleting, all those things will cause a lot of anomalies, and you need to avoid all those by keeping the proper referential integrity constraints. So your primary key constraint, the foreign key constraint are those constraints which will actually prevent all these violations, and you will see more in the lab. So these are all the certain ways that you could do that. You can have delete constraint that can cascade. So that means that if you delete something, all those changes are actually updated in the referencing tables. And delete set null. Say if you delete something, make sure that all the matching foreign keys are set to null. and delete set default. So you're by default making the values into some default values, like, say 0 or something like that, or you will say that it will fall onto some parent parent department or something. Then update rule, there is something like where if you're updating the primary key in the parent, you will update the value. So updating the department number attribute in the department relation with match and foreign keys in the employee relation would cause the integrity violation. And update constraint, so default one in the Oracle, we will see that when we learn the Oracle. And update cascade is whenever you do some update, the changes are reflected. And update set null as well, the same as your delete set null. So if you delete something, so the primary key is updated, the matching foreign key values also are set to null. So so that it can apply only to foreign key values that accept nulls. Okay, so you need to set that in such a way that when some updations happen, it is actually set to null. And then you can also make it into some default values. Then user-defined integrity. So the other integrity constraints which we have seen till now are basically the ones which is given by or by default in there. And there could be some user-defined integrity constraints as well, because for certain applications we have to come out with certain constraints for a particular portion of your project or asset. So maybe set of permissions, set of rules specified by the user, permits deviate to define business rules. So that is like, say, the salary of your supervisor has to be more than the salary of your subordinate, or the subordinate salary has to be lesser than the salary of the supervisor. So these are certain constraints which you can actually define. So that is nothing but user-defined integrity constraints. Now, what are the major challenges posed by multivalued attributes? So as I have already told you, like, multivalued attributes are those attributes where one attribute or one cell can have multiple values. Say a student has got multiple addresses, like college address or home address, and a student can have multiple phone numbers. So these are the various factors which you have to keep in mind. So these are the multivalued attributes. But these multivalued attributes can pose you certain challenges. So how are we going to deal with the multivalued attributes and its challenges, and what are the solutions for dealing with that in the relational database? We will see that in the next class in detail. Thank you so much.